I need to get my plugin. Okay. So, more of doing this because next stop is basically, last time I think what I did with the thing was introduce this idea, which, if I remember correctly, Chem 6A, in terms of my professor that I took this class from, did not care too much about it, so I don't care too much about it. Well, I don't remember, but when I took the class, it was last winter, and they don't seem to care about it, so I don't care about it too much. Uh, Although they do care about the other one that I had to write about, which is the energy level, the up motion and down motion arrow, which I will be having to talk about soon. It's just that I don't want to because I'm incredibly lazy and it's not worth it to do, in my opinion. But one thing that's easy to talk about is the radius of the molecules if it's positively or negatively cation or anion, whatever they call it. So again, I'm deleting all this painful process, but it's getting faster as I know what to do now. So now thinking about it, I should got rid of one more row, so it makes it easier. Um, uh, so this is a modified periodic table. As you can see, there's no noble gas, there's no hydrogen, or I believe it was lithium. No, not hydrogen, lithium. What was it called again? I totally forgot. So noble gas. I should know this one. It is forget it. Who cares? Who really cares? Oh no, helium. There's no helium, and what else am I forgetting on this graph? I don't know. This is basically a modifying one, which means that there's a lot deleted because it wasn't necessary for what I'm proposing here. Um, Although I believe when I took my final, there was a lot of emphasis on Lewis structure or whatever shenanigans. I have to talk about that later, which I haven't done anything about. If you look over here, I have put down this as incomplete. Everything here is incomplete, and I actually also include this as incomplete because I mean, I would by if when it's something is complete, it doesn't mean it's actually completed. It means that to a certain point, I have covered everything that the lecturer told me and more. For example, they never really care about this structure at all, but the EV. But what I'm trying to say is that at least I covered all the things that the professor covered. But if I haven't, I put incomplete next to them. I decided to do that because it just feels right because it's not complete yet. Yeah, and plus there's a lot of classes I need to write notes on anyways. So my thought process about how I do this is basically just basically wait until like a month. You forget everything I have, and then just review everything because you'll slowly remember whatever is taught. Like you took the test, you remember. Like although thinking about it, I forgot multiple times of what is in physics 2C, so I had to look it up in my textbooks and all that shenanigans. I do cite all my textbooks, so it's pretty much fine. But yeah, thinking about that's probably not the best way to actually take notes and everything. But it's my personal notes and it's information. Yeah, I don't know what I'm saying. I actually don't know if I'm citing it correctly too. If you look at my citation, what I do is basically all this weird textbook. It has some weird textbook that I never used on this document, but I studied it, so I put it in there. For example, transportation, climate change shenanigans that I never put in this document, but still put it in the works cited page, and all the lectures I know of. Oops. I'm not even sure if I did it correctly, but I'm pretty sure I did it correctly because it's a per years thing. Some of them are high school lectures, which is fine. I'm pretty sure I did it correctly. If I didn't do it correctly, someone will tell me. Well, all these are empty. Uh, yeah, there's a giant overview on everything I know. So everything I've been taught here and more. It's gonna keep on going on and on. And I'm gonna keep on adding more and more lecture, more and more citations on different textbooks I'm gonna use. So that's gonna be so much fun. Not really, it's not. Um, to be fair, I don't remember. Anyway, actually, as long as I show that, I don't remember how copyright works, but I'm pretty sure because this is a education phenomenon, which means that it is something that happens in real life. You can't. It's possible as long as you make your own thing. It should be fine. I think at least. I don't know. I should research more about this. I did research more about. I don't know. I'm talking to myself like nonsense. Uh, this is painful as hell. This is just painful as hell. It's more painful than you think. Just making this one by one. And also, the periodic table is given by my professor, which I'm pretty sure it was gotten in public domain. So I'm pretty sure I'm fine. If I'm not fine, well, I screwed myself over by using this periodic table. But pretty sure it's in the public domain. If it's not, then I just screwed myself over. Not really, because I'm pretty sure there's a clause on any problems with the PR table because it's a public domain. It's fine to use no matter what. But just in case, I'm pretty sure, yeah. That's what I remember. Anyway, I'm just modifying it like crazy anyway, so it doesn't matter. I don't know who made this PR table that means actually, thinking about it. Maybe I should find out, but I don't think I can find out because if I remember correctly, I just got it from the professor. So that's the big problem. I just cannot figure out who made this periodic table at all. I want to give them credit because I give credit to people that are made it in public domain, as you can see over here. I always make a footnote on where I got it. Like if I go in the start and I go to how to measure something, I always put like public domain image by Moradi. Moradi? Really? They call this a Moradi? Oh, that's funny. Yeah, I had to use this weird shenanigans once for multimedia because everything else was like copyrighted to and had like a CC label, which I didn't want to deal with. So Monis was the only one that had the public domain shenanigans, so it just took forever to find something that's in the public domain. Yeah, but even if it's public domain, you should always give them credit. So actually, I maybe have to find this 6 or maybe it was made by the professor itself. It might make sense then, but probably not because I know professors and how they act. They just take stuff from the public domain and use it because they're allowed to. Because education, if you have if it's education, you can use anything as in the public domain, or there's a clause in any copyright infringement or patents that if you're using it for education, you can take it and use it however you want. Kind of funny that's true, but it's true. And if as long as you're a professor, you're thinking in a logical place. And also for PR table, I'm pretty sure the numbers cannot be copyrighted, but the system can be. But the system only works if you're using it for non-educational purposes, from my knowledge. So what I'm gonna do is I forgot what cation and anion is, so I'm just gonna go up here and find the cation that I showed how to do. So we're gonna do cation. I forgot if I did the positive or negative thing. So what I'd like to do here, actually this looks pretty bad. It's fine. Yeah. So positive, positive, positive equal cat ion. So imagine Li minus plus So EXLI plus. That's an example of a cation. Yeah. So what's the purpose of this? Well, what the purpose of this is actually I need a better system to copy and paste the pluses. But the idea is that if we have a cation, there's a different trend that it follows. Um, um, and funny part is uh, the idea, if I remember correctly, is that it has a trend. I just it's the trend is it gets bigger. I'll just show you it. It's not bad if you know what the hell I'm talking about. If you have a positive cation somehow. Noble gas are very hard to have a cation, so we're not including them because you most likely won't have it because they have full valence electrons. They are full. They don't have any more to gain or decrease to benefit themselves. So the idea is uh, maybe I'll leave it like this for now. And this is minus. Let me get the blue one. I don't like that color. What color did I use? Green. And I don't want to use green actually. Right, fine. I'll use green just because to get consistent. You know, just to be consistent with what I said. So this is there. How do I want to say this? We're doing radii, atomic radii. We do want to. We want to atomic ray. Yeah, what did they call radii? I believe of of um, of what do they call it? It's an ionic compound for ionic. Ionic. I think it's just called ionic. Let me just highlight that there. Actually, I don't think I can highlight that because, yeah, actually I can't do that. What happens is that when I save it, doesn't work. I'm gonna have to re-highlight that later. Okay, so I don't remember if what I don't remember what I don't remember what it's called. Is it called cation? It's called ion. It's called cation. Yes, it's called cation. Minus equal cat. Oh, wait a second. Did I mess up? Did I mess up the whole thing? I always mess up. Is it cation or ion? I don't remember anymore. Cation is a positive, and then the ion, anion. Sorry, N and ion, I believe. Let's make sure. I thought I would get faster at doing this. It turns out I'm not getting faster. But yeah, we'll just keep on doing it. Cat ions. So there are cat